call in and we'll work those calculus problems together. Let's meet my student assistant for today.
Hi, my name is Eduardo Cantu. I'm in Ms. Brzezinski's calculus class at Sunset High School. I plan to attend the University of North Texas next year.
Eduardo, why don't you remind the students about the rules?
Avoid feedback by using the telephone in the classroom. Cell phones do not work. Turn down the set a little when you're on the air and sit back and relax.
We are counting down until the AP Calculus exam on May the 3rd. Eduardo, how many days do we have?
Let's get ready to rumble!
We should get right to work. Eduardo, who's our first caller?
Our first caller is Edgar from Sunset High School.
You know Edgar?
Yes.
All right, Edgar. Are you there, Edgar?
Yeah, I'm right here.
Hi, how are you today?
Hello, everybody.
Huh?
How are you?
I'm chilling.
Good. Eduardo's going to look the picture up while we start a problem, okay? All right. Are you ready?
Oh, man.
Oh, it's okay. Take a deep breath. You ready?
Yeah.
This area is 5. The area under the curve is 5. This area is 3. Oh, look, it's below the axis. And this area is 2. For the first step, would you just tell me the integral from 0 to 6 of the function? Let's just do that first. 0 to 6, the function. What are you going to do with all these numbers? Integrate means do what with this, and what with that, and what with this.
Can you say that again?
All right, to integrate, what do you do with 5 and 2?
Accumulate, add them all?
That's right, you're going to accumulate and add them up.
That's
What about
right.
this 3? What's going to happen to it?
Negative.
That's right, you're going to subtract. So
That's
5,
right.
take away
Minus.
3,
Yeah.
plus 2.
Plus
Tell me
2.
what you get. What do you get?
4.
That's
we're losing him.
exactly right. Now let's do the second part. The integral from 0 to 6 of 2 with respect to x. How do you integrate 2?
2x.
That's right, with your plug-ins, right?
All right.
And so what do you get when you multiply it out? What do you get? 2 times
6.
2 times 6, take away
12.
2 times 0.
Oh, my bad.
No, that's right. You're exactly right. It's 12. I was just going to, just so we thought about it. Now, the final answer is to put these two together, and what do you get?
Hold up, I can't hear you.
What do you get when you add 4 and 12?
Oh, damn, I'm over here tripping. 16.
Yeah, that's right. It's just 16. This looked kind of hard, but if you break it into pieces, you know the integral from 0 to 6, or you can count that, and then integrate 2.
I did it!
And do integrate of 2, okay?
Okay.
Hey, you did a good job on that. Now, we're going to show you
Hey,
a picture.
that was easy.
Nah, you don't gotta do that.
Oh, come on. We're going to show you a picture. All right. Very nice. Look at this. Right above you.
Who's red button? Oh,
Eduardo! Excellent.
why
Hey,
you so shy?
thank you guys for calling in. I appreciate you calling. Call back, okay?
All right.
Bye-bye. Who's our next caller, Eduardo?
Our next caller is Rodolfo from Skyline.
Rodolfo had to leave, so Gloria was calling for him.
Say it again. Who's calling?
Gloria?
Oh, Gloria. Hey, Gloria, you're going to be on the show. Excellent. I'm looking forward to meeting you. Gloria, what's your last name?
Medina.
Medina. Thank you. I'd forgotten. Do we have your picture?
I believe so.
All right. Under Skyline, that's going to be Miss Johnson's class. Are you A, B, or BC?
BC.
Ooh. I'm going to give you a hard problem. No, it's not too hard. Let me get it where you can see it. Uh-oh.
Oh, I can't see.
I know, I can't either. Okay. Sometimes the machine just gets away from me. Now, can you see it okay?
Uh-huh.
E to the tan of x over the cosine squared of x. Oh my goodness, what are you going to make sense of that?
Hello, 1 over cosine is secant squared.
Oh, good job.
That's
The
right.
tan of x, and this is secant squared. Why do you like the fact that that's secant squared?
Because secant squared is the derivative of tan x.
There you go. You've got e to the u with du just sitting there. Do you want me to go ahead and just use 0 and pi over 4? Mm-hmm. All right. So let's think. The integral of e to the u is?
E to the tan x.
There you go. That's our favorite, isn't it?
Well, from 0 to pi over 4.
That's right.
I'm going to have to move out just a little bit because I'm writing too big, I think. All right. And now we plug in e to the what? You tell me.
E to the tan of 0.
Tan of which one first?
Oh, pi over 4.
There you go. Minus
E to the tan of 0.
Excellent. And so what do we get when we say tan of pi over 4? I'm thinking.
It's e to the 1.
Oh, good. Minus
e to the 0.
Is e to the 0 equal to 0?
No, it's
No,
equal to
you gotta be careful. It's equal to, say it again,
1.
e minus 1. How's that for an answer?
Good.
That is a very good answer. Scary problem. Give her the bell on that was a scary problem, but you handled it beautifully. You knew there only one thing you can do with integral of e to the u. You got to have du, right?
Yes, ma'am.
And you found it. It was waiting on you almost.
Okay.
Thank you for calling. I look
See you
forward to
next
seeing you on the show next
Okay,
week.
bye-bye.
I'll see you then. Bye-bye. Who's our next caller, Eduardo?
Avante?
Hey, Avante.
Hello.
How are you? How are you, Avante?
Alright.
Did you get your gift card?
Yes, ma'am.
Have you spent it yet?
Yes, ma'am.
Oh, what'd you get? Can you tell us?
Got a CD.
A CD. Which one?
The Gorilla.
Say that again?
The Gorilla.
Do you know about that? The
Yes.
Gorillas? Oh, I'm the only one here that doesn't know. I'm going to look that up, okay? All right, Devontae, here we go. I'm glad you called back. Yeah, who knows? You might win again, right? This related rate problem?
Yeah.
Is that your favorite thing to do in the whole world? No, not quite.
I like derivatives.
You like derivatives better?
Yeah.
We're going to get some derivatives out of this problem. All right, the radius is increasing at a rate of, what do you want to call that? D what? It's a radius.
DR.
The RDT works for me.
Yeah.
0.3. I'm not going to put the units right now. What's the rate of change in the what?
I can't see that.
Oh, it says area of the circle.
Oh, okay.
So we want dA, right?
DA, DT.
That's what we're looking for, dA dt. When the circumference is, okay, we got some more information, 30 pi. All right. Now here's the deal, Ivante. We've got to relate area and radius and circle. Do you know any formulas that will tie together area and radius and are about a circle?
Let me think for a minute.
Take a minute, come up with a good answer. Area equals,
Power squared.
there you go.
Alright,
And
yeah.
see, it's one you know. It's not going to be, if it's going to be something you don't know, they're going to give it to you. All right, now let's take a derivative. dA dt, that's easy. I'll do that one because it's easy. Now you do this one.
Pi.
Pi,
R.
dr dt, right?
Oh, I'm sorry about the unit. Yeah.
There you go. All right, now what do we know? Well, we know dr dt. We're looking for this, so we're not shocked that it's still missing. I'm going to call this 2 pi. Is that okay with you?
Yeah, that's okay.
I need r, and I've got 0.3. Uh-oh, I've hit a roadblock.
Okay.
How am I going to find r?
The R is half of the circumference.
Ah, good idea. The r is, this is circumference is 2 pi r,
Yeah.
and so 2r is 30, so what's 1r?
15.
There you go. Excellent. I'm going to put 15. We got here and we were kind of stuck, so we had to think, look around, see what we knew. All right, so all we need to do is multiply 2 times pi times 15, and I'm going to say 3/10. Is that okay with you? Can you clean that up a little for me? What do you get?
45 by 2
Did I write what you said? 45 pi over 10 times 2?
Yeah.
And what does that clean up to?
9 pi.
Oh, beautiful. That is a great answer. Now let's think a minute. This is area, the rate of change of area. We're in meters and seconds, so what are my units going to be? If it's area, it's not just plain meters, what is it?
Square.
Meters squared per second. There we go. I kind of flubbed on that one, but that's okay. What do you think? Is this now your favorite kind of problem? No. Give him the bell. He did a good job deciding his favorite problem. And a round of applause. Thank you for calling in, Avante.
Same time next week.
Excellent. We look forward to hearing from you. Who's our next caller?
Our next caller is Maria from Adamson.
Hey, Maria. Hi. How's everybody at Adamson?
Fine.
Do you know what's happening on Saturday?
Yes.
What? Tell us.
It's gonna be the prep session.
That's exactly where it is.
Yeah, it's gonna be at Townview.
Townview. And Eduardo, what are the times on the When do we start and when do we stop?
From 9 to 2:30 p.m.
9 to 2:30. We want to be there the whole day, don't we?
Yes.
Excellent. All right. Let's see. How do you like use substitution?
Oh yeah. I love it.
You love it. All right, here we go. Without integrating, look, I'm giving you a break. You're not going to have to integrate. You're just going to set it up for me using U. I even told you what U is. Turn this into the equivalent. So I want U to be this, and then what else do you need to know?
The derivative of U.
Derivative of U.
3dx.
Perfect. Do I have 3dx?
No, but we can put 1/3 outside of the...
1/3 outside.
No way, dude!
Integral. U squared du. Now, did I get that all like you wanted it?
Yeah.
Now we need to change our limits. If I go ahead.
It's gonna be 1, -1. The bottom one, yeah. And then the other one is 2, right?
Say it again. I just didn't hear that. Go ahead.
It's gonna be 2.
What's the bottom limit? I think you said it. I just couldn't.
Yeah,
hear.
the bottom is gonna be -1.
Excellent.
And the other one is gonna be 2.
The top is 2. That is perfect. And when they say without integrating, you get to stop right there. Isn't that a beautiful problem?
Yes.
Very few kids got it right on the last AP exam. Do you know that?
No.
You were better than all those other kids, right?
Yeah.
Going on the way to your 5. Hey, thank you for calling in. You guys call back.
Okay.
Bye.
Bye.
Who's our next caller,
Our
Eduardo?
next caller is Veronica from Sunset.
Hey, Veronica.
Hey.
How are y'all doing?
Good.
Let me show your picture. There you go, Veronica.
Hey,
You look great.
can I say hi to Veronica?
Of course you can say hi. Go ahead.
Hi, what are you doing?
Hello, everybody!
Y'all gonna have a little conversation here? I'm glad you called in. Next week, we've got a young lady from Skyline, and then, you know what, guys? I could use some more student assistance. Tell your teachers to email me. Okay, here we go. The graph of the derivative is shown above. What is this?
The what?
The derivative.
The derivative.
And I'm going to write it 3 times so I don't forget.
Okay.
This is the derivative. Can you see it's positive here?
Yeah.
And negative. This is 1 to 2, 1 to 3. Those numbers are a little hard to see, but that's 1 to 3. All right, true or false? F of x is decreasing between 1 and 3.
True.
How did you know that? You're exactly right. How'd you know that?
Because it's below the x-axis.
Because the first derivative is below the x. That's exactly right. That's how you knew it. The first derivative is negative. The graph of the function is concave up between 1 and 3. True or false?
No, it's false.
You said false. Why did you say false? You're right.
Because it's decreasing from 1 and 2.
That's right. So from 1 to 2, we're getting concave down. This is all concave down talk and concave. Good job. F of x has a relative minimum here at x equals 1. Is that a relative minimum on the function?
No.
No, false. It's a relative what?
Max.
Exactly, because the first derivative changed sign from,
From what?
what did the first derivative change signs from what to what?
Positive to negative.
Excellent. You did a great job. This would be one of those that would have 1 only, 1 and 2, 1, 2, and 3, and you have to look at each one and then come up with your final answer. You did a great job on that. I like the way you're looking at those derivatives. Hey, thank you for calling in.
Bye.
You get the bell. Excellent. Exuberant bell there. We like that bell. All right. Who's our next caller, Eduardo?
Our next caller is Brittany from Skyline.
Huh?
Who's your teacher?
Miss Johnson.
Miss Johnson. Did you say, tell Miss Johnson I said hello, okay?
Hi, Miss Johnson. She said hello.
Hello, everybody!
I want to be sure Miss Johnson knows I'm thinking about her. All right. I don't know if you've done this or not, so you can help me, we'll see if you've done this, okay? Given a particle moves such that you know 2 things. You know the velocity at 3 is negative 0.231. And you know the acceleration at 3 is negative 0.445. And here's my question. Is the particle speeding up at that time? And justify your answer.
Yes.
Thank you. Yes. And how did you know?
Because both velocity and acceleration are negative.
Very good. If the velocity is
Hey,
negative
that was easy.
and the acceleration is negative, the particle's speeding up. What if they were both positive?
It's speeding up.
It'd be speeding up. But if there's one of each, one of my students put it this way. He said, if one's positive, one's negative, they're working against each other. And that's slowing down. I like that because it's hard to think about negative velocity. I don't drive my car negative 40 miles an hour, you know. But it's
That's
great,
right.
isn't it? Oh, you did a great job. Thank you very much for calling in. You guys call back. I got to tell you to give the bell.
Our next caller is Crystal from Carter.
Hey,
She's fine.
she's fine? Good. All right, you going to the prep session on Saturday?
Yes, ma'am.
You know, we've got calculus and statistics meeting Saturday. Are you in statistics?
No, I'm in calculus.
So you can do calculus all day long.
Of course.
Of course. What more would you want? Okay, I got a problem for you. A lot of people missed this on the last test, but I think you're going to know just what to do.
All right.
You got a line tangent to the graph of the function at a point 1, 2. That's a point on your graph. And that line, and that's a tangent line we're talking about, passes through the point -5, -5. What's the slope of the function at 1? You know what to do?
You have to find the slope of the tangent line.
Right. And how are you going to find the slope of the tangent line?
Using both of the points.
Exactly. That's all you got to do. This is a point. Let's draw it on the graph. Do you mind making a little drawing? The point 1, 2. And that's a point on the graph. So I'm going to make a little, you know, like the graph. And then -5. 1, 2, let's see if I counted that part. And -5. And so these 2 points connect to make, so all you got to do is find the slope like your Algebra 1 teacher taught you. All right. Okay, do it. Find the slope. Tell me what to write.
It's -5
-5.
minus 2
Good job.
over -5 minus 1
All right, clean it up. What do you get?
to be -7 over -6.
And one more step.
7 over 6.
Good job. Does it look like it's a positive slope?
Yes.
Yes, it does. So we feel pretty good. A lot of students miss this problem, and I think they just didn't realize how simple it was. They probably got nervous when they saw those words, right? That happens to us. Double bell. That's a double bell problem. That is just like a real live AP question, so I'm glad you called.
All right.
Thank you.
you.
Call
Our next caller is Noel from Townview.
Hey, Townview, you there? Townview? Nolan?
Nolan.
We
Our next
got
caller is
Nolan
Nolan from Townview.
Nolan, are you there? Nigel. Hey, is it Nigel?
Yeah.
Hey, Nigel, I'm sorry we're calling you the wrong name. I think that's another caller later. How are you doing, Nigel?
I'm good. How are you?
Good, I'm fine. Mr. Sanford, one of our best, right?
Yes.
Is he listening to you?
Hello, everybody.
Yeah, she's gonna give me an A too.
I was going to say extra credit for you, right? All right, so let's see if you like this problem. I got a little problem here for you.
Thank you.
Right, how's that look? Do you like that one?
No, but I'll do it.
Okay, and I may want to slow you down a little because you're probably going to work it so fast that I may slow you down, okay? All right, tell me what to do.
Well, let's see. You have e to the 3x on the inside, so that's probably gonna be your u.
Yeah, baby.
That's a good idea. Let u be e to the 3x. Speak up just a little bit so we can hear you.
Okay.
Okay, thanks. And then what do you need to do next?
Well, now you need du,
That's true.
and du is 3 e to the 3x dx.
You did that very well.
Right.
And now what are we going to do next?
And now you have a 3 by the wait. Oh yeah. So now you substitute everything, I think. But you don't
Okay.
have a 3 in there, so you have to put a 1/3 on the outside.
I'm going to put a 1/3 outside. I'll do the integral sign.
Yeah, and then so then you just put u du. No, sine of u du.
Sine of u and du. Shall we change our limits? Why don't we do that? When you plug a 0 in, what do you get?
You get 1
1. Good job. When you plug a 1 in, what do you get?
e to the 3rd.
Excellent. And now continue. Do you know how to integrate sine? That's rhetorical. I know you do. What do you get?
Negative cosine.
All right. That's good. Don't forget that negative, right?
Yeah, right.
If we forget it, we're going to miss all these problems.
Then I fail.
And we're going to do our plug-ins. You ready?
Yes.
What do you want me to write?
Negative cosine of e to the 3rd. Well, 1/3
Okay.
times, parentheses. Well, okay, yeah.
You want me to put the 1/3 out front?
Yes.
Or,
Yes.
okay.
Okay.
Now Now, should I put it positive, make that negative, or are you going to keep track of the
Yes,
signs?
put a positive and make that negative.
Okay. Now I'm going to have to squeeze it in. There we go.
Right. Minus.
Take away.
No, plus.
Plus.
Cosine of 1.
All right. And so we've got 1/3. We could say cos of 1 minus cos of e to the third, right?
Yes.
Do you know what cos of e to the third is? No, of course not.
No.
No. This is a good answer. We're perfectly happy with this answer, aren't we?
Yes, ma'am.
Hey, listen, thank you for calling in, Nigel. Did I get it right, Nigel?
Yes.
All right. Thanks for calling in. You call back, okay?
Okay.
Thanks, guys.
Oh,
righty then.
Our next caller is Taryn from Skyline.
Is it Karen?
Terrence, yes.
Spell your name.
Terrence.
T-E-R. Okay, good. Who's your teacher, Taryn?
Miss Llewellyn.
Miss Llewellyn. Thank you for calling in. All right, let's see what we got here. Do you like
Hello, everybody.
limit problems? Do you like limit problems?
Yes, ma'am.
No way, dude.
Thank you. That's good. I don't have a limit problem. Can I give you another one? I'll give you okay. Thank you for being so agreeable. All right. I've got a function here, f of x, and it's one of those rational functions. It's got fraction stuff going on. I want to talk, let's just do increasing, decreasing. Where's the function increasing, decreasing? What are you going to do? How do you solve this kind of problem?
Oh, low D high
Okay. Low, d high,
minus high D low
high, d low, over.
over low squared.
Good job. So that's your quotient rule. Thank you for telling me the rule so we'd all know which one, because everybody does a little different. We all get the same answer in the end, right? All right, tell me what to do next.
Low is x plus 2 times root to a high, which is 1,
Okay.
minus quantity of x minus 3 times 1
Good job.
You've
over
got to prioritize.
x plus 2 squared.
Excellent. Keep going.
So that'd be x plus 2 minus x plus 3.
Excellent. You carried that sign very, very well, Taryn. Thank you. Over. And we'll just
That's
leave
right.
this, won't we? Clean up the top for me. What do you get?
5 over x plus 2 squared.
Okay, here's my issue. I like this. You did fine. There is something going on at where in this function? Look at the original
Where x
function.
equals negative 2.
Right, where x equals negative 2, you've got a what? What have you got?
Asymptote.
That's right, you got a vertical asymptote. So we're going to have to consider that on our graph. At negative 2, we've got an undefined derivative. That's okay, but our derivative tells us about our function. All right, this is going to be positive everywhere, isn't it?
Yes.
Except here. So we get positive and positive. We could plug in, but when you square the bottom, it's going to be positive, isn't it? So function's going up, make a break, and going up again. So tell me where the function is increasing.
It's increasing from negative infinity to negative 2 and from negative 2 to positive infinity.
You did that just right. You can't say negative infinity to positive infinity. That's just not true. But it is on these two pieces of the puzzle. It's going up, going. This is one of those whoosh whoosh functions, isn't it? Going up and going up again. Something like that, right?
Yes.
Great job. You did a good job with that. Double bells on. Thank you for calling in. You called back. Here's our next caller.
Our next caller is Stephanie from Sunset.
Hi, can you say hi to Eduardo?
Hi, Eduardo.
Hey, Stephanie. What are y'all eating?
Yeah, what have y'all got for refreshments today? Here you go, Stephanie. Very nice.
Sure,
like
you
your
guys.
jacket.
Whatever.
Thank you.
What do y'all have for refreshments today?
Coke.
Coke. The breakfast of champions, right? And what else? What else do you have?
Lasagna.
Oh, really? Man, y'all are having a real feast over there. I invited your dean to watch. Did she come by yet? She may be watching in her office. She's going to watch a little bit today to see what it is, okay? All right, here we go. You ready?
Yes.
Okay.
She's like,
This is the second derivative. I told you here, and I've told you here, and I'm going to tell you one more time, okay? 'Cause when they
Yeah,
say something like that,
baby.
they usually write it more than one time, so you don't forget that it's the second derivative. Notice the second derivative has
Whoa!
some positive, etc. Where does the function f have a point of inflection? What are you looking for? That's where this one appears to have, but this is not f, this is f double prime. So think again, let's think again. The second derivative, what does the second derivative do? If this were the function, you're looking at concavity, aren't you? That's what you're looking at, right? You want the second derivative to change signs. That's what you want. Change signs. All right, look right here. What's happening here? Does the second derivative change from negative to positive?
Yes.
It does. So that's
Cool.
POI. On the function. We're not looking at the function, are we? It's hard to think about sometimes. We want to think it's the function. Now look over here. Is it enough that the second derivative goes 0? No, it's got to what?
Change signs.
Change signs. If the second derivative does not change signs, you do not have a POI. So you're going to stick with this one answer no matter what anybody says, right?
Yes.
That's right. And remember, this is the second derivative we're looking at, so don't fall for that. Don't let them lead you to think it's the function, because it's not. Okay?
Okay.
Thank you for calling in. Good job. Bell. You can give an extra bell. Who's our next caller?
Our next caller is Jose from Carter.
Hey, Jose.
Hello.
Hi, how are you doing? I saw a Carter athlete in the paper this morning. Maybe a track person. Did you see that?
No, not really.
Oh, it was a wonderful picture of one of your juniors. I think he's a junior. He's number 3 in the class. Does that ring a
I
bell?
don't know.
No, I didn't remember the name, but I'll look it up again when I get home. All right, have you guys done derivatives of, I know you have, so I'm just going to put it up here. You
Cool.
ready?
Yeah.
My machine's kind of going nuts here. I think it's better now. Find the derivative if y equals the cosine cubed of x to the 4th. Do you know what to do to that?
I can't hear you.
Oh, can you not hear me? Are you okay? Are you there?
Yeah, I can hear you now.
Okay.
What did you say? What did you say?
All right, we've got cosine cubed x to the 4th. Would you like me to rewrite it?
Yes.
Cosine x to the 4th cubed, is that better for you?
Yes.
Okay, good. Let's list what we've got. We've got a power,
Yes. It's chain rule.
and we've got, that's right, we've got a cosine, and we've got an x to the 4th. We got to take care of all that. All right, let's do it a step at a time. Do your power rule first. What do?
Bring it down.
Bring it down. Let's keep this just the same. Don't go messing with it, right?
Yep.
And what do I put for the new power?
2.
Good job. And now what's the derivative of cosine of this stuff?
Negative sign?
Great. Negative sine of this stuff, right?
Yes.
And then what's the derivative of x to the 4th?
4x cubed.
That is beautiful. You got everything just right. Notice these two have the same thing inside the trig function. You don't start taking the derivative before you get over to here, right?
Yeah.
All right, let's clean it up. 3 times 4 times a negative all comes out front. What do you get?
Negative x cubed.
And what number goes in front?
12.
Very good. And then cosine squared.
Yeah.
Good. And then,
Negative sine x.
and again, notice these two have the same little thing in there. If they don't, then we probably got carried away and took derivatives too fast.
Yeah.
Hey, that is beautiful. You know what? They usually put one of these on there. Out of your 45 questions, this is one in your pocket, isn't it?
Cool.
Good. Cool. All right. Call back, you guys.
right.
Thanks for calling. Good. Thank you for the bell. Who's our next caller?
Our next caller is Maggie from Addison.
Hey, Maggie. Hi. What kind of refreshments have y'all got, Maggie?
Just none.
None. Oh, no. What happened? Did Mr. Bentley forget?
Yes, he did.
Oh, you know what? I've done that before. Doesn't take too many times. We're going to do an average value of the function, okay?
Sure.
Are you coming Saturday?
Yes, I am.
Excellent. Step back a little bit from the TV set so we don't get feedback, okay? Can you step back a little and still see?
Yeah.
That's good, okay. Average value of the function on the interval 1 to 9. Do you know how to do the average value of a function?
Yes, I do.
All right, you want to tell me a formula?
1 over b minus a times the integral of the function
Okay, what else?
dx. And your limits.
That's right, A to B. Good job. And right, the dx, I do like to make sure I put that. That just makes the problem really correct. I had a student who went to SMU, and her first test she got a 99. Guess what she left off?
dx.
I know, she lost a point for that. Okay, let's fill it in. What do I fill in for B and A?
1 over 9 minus 1.
Good. Integral from 1 to 9. Can I write it x to the 1/2? Is that okay?
Sure.
All right. And now, what's this?
1 over 8.
All right. You ready to integrate?
Yeah.
Okay, tell me what to write.
X to the 3/2 divided times 2/3.
Good job. And then I've got my plug-ins, right?
Yeah.
Did I leave anything off? I think you said everything. I just hope I wrote everything you said, okay? You want to clean this up just a little bit? Well, maybe we better not. That's okay. We don't have to. We'll do it this way. 2/3 what?
Times 9.
Good. To the 3/2 minus 2/3 times
1.
1 to the 3/2. We don't really care, do we? All right. 1/8 times 2/3. And now we get to the fun part. How do you take the 9 to the 3/2?
You take the square root and then cube it.
Exactly. Tell me what you get.
27.
Beautiful. Take away. Let's see. 1. What are you going to get?
1.
Oh, yeah. That's easy. We like that one. All right. Can we finish it up? What's 2 times 27?
54.
54 over 3.
Over 3.
Take away 2 over 3. What's that equal to?
52 over 3.
That's right. 1/8 times 52 over 3. And you know, I could call that 52 over 24, or I could divide by 2 and call it what?
12 over... oh no. What's the number?
52 over 24.
Oh.
Divide top and bottom by 2, maybe?
Oh, 26 over 12.
Perfect. And you know, in a free response, you don't have to do all that. You could stop way early, like even here if you wanted to. Right? Hey,
Yeah.
thank you for calling in. You did a good job. Bells all around.
So that's your final answer.
Who's our next caller, Eduardo?
Our next caller is Hong An.
How are you? What school?
Skyline.
Skyline. Thank you for calling in. How are you today?
I'm good.
Who's your teacher? I'm fine, thank you. Who's your teacher?
Johnson.
Miss Johnson. All right, I got a problem for you here. This could take you a microsecond, possibly. Let's see how long it takes.
Okay.
Let's get the machine to quit going crazy. Can you see that? It says the derivative with
Yeah.
respect to x.
Yes.
Uh-oh, hold on. I'm not doing anything. It's just going nuts. I think we've got haunted ghosts. From 1 to x squared sine of t dt. Do you know how to get the derivative of the integral?
Yes. I'm going to use the second fundamental theorem of calculus.
The second, I like the way you talk. Go for
Thank
it.
you.
What do you get?
I will have it equals to sine of x squared times 2x.
So, pardon me, that was me messing up. Times 2x. That is a beautiful job. You know how many got this right on the last test? Not many.
Oh, really?
30% got it right.
Okay, thank you.
You're gonna make a bunch of points, aren't you? Hey, it's good to hear from you. You were in the class I worked with earlier, weren't you?
Yeah.
When Miss Johnson had to be out a few days. Yeah. Nice to hear
Oh,
from
yes.
you again.
Okay,
Thanks
thank
for
you.
calling. Bye-bye. Bells all around. Thank you. Who's our next caller?
Next
Eduardo?
caller is Jonathan from Sunset.
I'm alright.
Do I have your picture?
You might have it.
I might have it. Let's see. Yes.
Eduardo.
There you go, Jonathan. Got on a leather jacket. What'd you get your jacket for?
Football.
Football. you a senior?
Junior.
You're a junior, so you can play again next year, huh?
Yes, ma'am.
All right, let's see if you can solve this problem. It's a little faint. My printer kind of went nuts for a second and went blue instead of black.
Is it easy?
It's very easy.
All right.
Trust me,
Back to work.
it's easy.
Back to work. Everybody. Work, 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 work.
Limit
work,
is
work.
h goes to 0 of cos of x plus h minus cos of x over h. Do you know what that is?
Wow.
Definition of derivative.
Oh, man, you're good. It's the limit definition of the derivative. So what am I really wanting you to do?
Cosine x. Find the derivative of cosine
That's
x.
right. Y equals cosine of x, and I want the derivative. What is it?
Negative sine x, I believe.
Perfect. The minus is in the function because this is just a slope, isn't it?
Yes, ma'am.
Just a slope. You did a great job. That's
Thank
the
you.
kind of question where they don't expect you to work it the long, hard way. They expect you to know just what you knew. My function is cos of x. Take a derivative. Beautiful.
Thank you.
Knowing that kind of problem and being able to really get it fast, that's really good. Who's our next caller?
Our next caller is Desmond from Kimball.
Hey, Kimball.
Hey,
Hi, how are you doing today? Have I heard from y'all so far today?
no man.
Well, excellent. I'm glad you called in. How's Miss Brzezinski?
How are you, Miss Brzezinski? She wants to know. She wants to know how are you? How are you?
Couldn't just tell by looking, right? Hey, have you guys done arcsine and arctan?
Yes.
Okay, Desmond, hold on.
No, we don't.
We'll show you a picture first. Yay.
Oh,
Hold on. Excellent. All right, Desmond, what did you say?
Wow, you did pretty cool.
Yeah, baby.
Are you telling the story or are you telling the truth?
I'm telling the truth.
All right, I got a problem for you. You ready? Here
Yeah.
we go. Doesn't have anything to do with arctan and arcsine. You'll probably do those pretty soon, right? Have you
Yeah.
really done them? Tell me. Were you just playing with me?
No.
Oh, okay. Integral from a to b of f of x dx is a plus 2b. Got it?
Yeah.
I want the integral from a to b of f of x, oh, wait a minute, plus 5. What are you going to do?
Split them.
Split them. I like that. A to b of f of x. Tell me what to write.
Plus, integrate from A to B, 5 dx.
Right. I better put the dx. That SMU professor would take a point off, wouldn't he? Okay, go for it. What is this equal to?
A plus 2B
Yeah, they gave it to you. A plus 2b. All right.
plus
What's our next one?
5 dx.
5 what?
Oh, 5x.
5x.
Yeah,
Good job. From what to what?
A to B.
Right. We've already done this one, so this one's finished, isn't it?
Yeah.
So I'll just keep writing it. All right. What do I need to put here?
5B minus 5A.
That is great. That's exactly right. Now, can you clean it up?
Plus,
Yeah, we'll go ahead and write it out.
okay. Plus,
Since the plus in front's not as bad, is it?
5B minus 5A.
Good job. Now,
Okay.
what does that give you? Net result.
Okay, 4A.
That's right.
Okay.
What's that?
What, did you say 4a
Yeah.
or negative 4a?
Oh, yeah, right. Oh,
All right.
my bad.
I'm not going to charge you for that. That was free. Okay. Negative 4a plus what?
Plus 7B.
That's excellent. That is a great job. That problem is a hard problem for a lot of people, and you knew exactly what to do. I like splitting it up. Here's the part you know. Oh, this is easy, isn't it? That's easy once you realize that's all you got to do. You know what most students do? What do most students do? A plus 2b plus 5. They don't do that. They just put plus 5.
Oh.
Thank you for calling in. Good job. Excellent bells.
Okay.
Who's our next caller, Eduardo?
Our next caller is Courtney from Soundview.
Hey, Courtney.
How you doing?
I'm fine. Who's your teacher?
I didn't hear you. What you
Who
say?
is your teacher?
Miss Hines from the Science and Engineering Mag.
You're from Science Engineering, and who's your teacher?
Miss Hines.
Hello, everybody.
Miss Hines.
Hello,
I'm sorry,
everybody.
You said that
Hello, everybody.
fast enough. All right. I know Miss Hines. My ears were not working. All right. So if you guys, what have you been working on? I want to. Have you done e to the u? Have you done derivatives and that kind of thing?
Yes, ma'am.
Great. Because different people do different sequences. All right, look at these two, and I'm going to
How you doing?
one you want to work. Do you want to work quotient rule or product rule?
I'll take the second one.
The second one for $50, right? Oh, never mind. I don't have $50. Okay.
Good
3x
answer.
and e to the 5x. Tell me what to write. What is your product rule? Tell me what you use, and I'll write it up here for the group.
Okay, u will equal 5 over x.
Say it again.
Okay, u will equal,
It's going to be a product rule, right?
We're losing him.
X times e to the 5x.
okay.
And how do y'all do product rule? Like some people go v u prime, take, that kind of thing. What do you say?
Okay, so I would do first times the derivative of the second.
Okay, the first times the derivative of the second. Tell me what to write.
It would be e, okay, it'd be 5. 5e to the 5x
That's exactly right. The first times the derivative of the second. What's next?
plus the second
The second. I'll write that for you, okay?
times the derivative of the first, which is 3.
3. Now let's look at this. I could take out, what could I take out? Factor.
A 3.
A 3, and what else?
But I have to take out a e
To the 5x, right? These work out that way, right? Because you're going to have e to the 5x in both the original and the derivative. All right, when I take out a 3 and an e to the 5x, what's left?
You have a 1. Okay, you have a x,
I have an x, what else?
and you also have a 5.
That's exactly right. And when I take out an e to the 5x and a 3 from here, what do I have?
You have a 1.
I have a 1. Now let me ask you one more question. That is beautiful. You did a good job.
Fine.
One more question. Is e to the 5x ever negative? Is e to the 5x ever negative?
No, ma'am.
No, this is always positive, isn't it?
Yes, ma'am.
Always positive. Just this part now. I'm not talking about this part. So if I had to set it equal to 0, this is the one that would go to 0, right?
Yes, ma'am.
Yes, it would. Hey, thank you for calling in. I appreciate you guys. Here's our next caller, Eduardo.
Our next caller is Lisbeth from Skyline.
Hi. Hi. Say your name again.
Excuse me?
Say your name again.
Lisbeth.
Lisbeth. Okay, I thought that was it. I wasn't sure if I was hearing the first part right. Well, how are you today?
I'm fine. How are
Excellent.
you?
I'm doing very well. This is Thursday, right? Yay. Aren't you glad it's Thursday?
I hope it was Friday.
I know. It's coming soon. Here we go. I got a problem for you. This is the derivative of a function. This goes up to 3 and over 2. I don't know if you can see those numbers. It goes up to 3 and over to 2. This is the derivative. What did I say it was?
The derivative.
I'm going to write it 3 times. If g of 0 is 15, that's the function now, not the derivative, and g of 2 then would be blank. What do you do? This is the derivative from 0 to 2. How would you turn the derivative into the function? How do you turn a derivative into a function?
You integrate.
You integrate. Let's integrate from 0 to 2 the derivative. Now, why did I pick 0 and 2?
Because the interval is the limit between 0 and 2.
That's what they're talking about. I picked what they're talking about. I could have integrated from 5 to 10. Wouldn't have done me any good because I don't know anything about 5 and 10, do I? I know about 0 and 2. What happens when I integrate g prime? What do I get? G of
G of 2.
2, take
minus
away.
G of 0.
Excellent. Now let's see what we can fill in. What's g of 0?
15.
Oh, they gave us that. Okay. What's g of 2?
Unknown.
That's what we don't know. And what's the area under the curve from 0 to 2? The integral from 0 to 2. Up 3 and over 2. What's the area of that triangle?
3.
That's right. It's 1/2 base times height, right? It's just 1/2 base times height. So how do I get g of 2?
You add 15 to
That's
3.
right. What do you get?
18.
That is a beautiful problem, isn't it? It's using your fundamental theorem of calculus. Good job. Bells, whistles. and knowing that to go from the derivative to the function, well, I integrate, right? Thank you for calling. Who's our next caller? I think I
Next
lost-
caller is Kristen from Adamson.
Hey, Chris. Y'all must have the best phone in the world.
Yeah, we do.
Excellent. I'm glad you're calling. You going to be there Saturday?
Yes.
Good job. You going to go hear different teachers or go just sit and hear your teacher? What do you believe?
No, we're gonna go to different teachers.
You got to different teachers. See, I think that's a good idea too, because you hear your teacher. Your teacher's very good, but I always tell my students, go hear somebody else, because you get to hear me every single day, right?
Yeah, exactly. That's what I say too.
Yeah. Although, you know, you got to watch. You don't want to act like you want to hear another teacher, right?
I mean, yeah, we want to see another teacher, but
That's
we want to
right.
hear our teacher too.
That's right. You got to act reluctant, and then you can go ahead and go do what you want.
Because our teacher is the best.
Your
Yay!
teacher is the best. Yay! All right, here we go. I've got a function for you. I've got a picture here. I'm kind of stumbling over my problems here.
Yeah.
Let me get them right for you. I've got a picture.
Yes.
Let's see if I can get it where you can see it. Oh, there we go. I can't drive this machine sometimes. This is -1, 0, 1, and so on. I want to know if the function is differentiable at x equals -1. Is the function differentiable at x equals -1? What do you think? Can you take a derivative there?
I mean,
A function needs to be smooth and easygoing. So the answer is, say it again,
it's not differentiable
it's not. Tell me why.
because there is a cusp.
That's right, there's a cusp or a sharp turn.
Yeah.
You can also say the derivative from the left does not equal the derivative from the right. That's another way to put it. The
Yeah.
derivative from the left is a solid constant. The derivative from the right is another constant, right?
Yeah.
And they don't match. Here's my second question. Is this function continuous at x equals -1?
Yes.
Yes, it is. So they might say to you, at which point is the function continuous but not differentiable? And you'd be looking for something like that.
Exactly.
Is the function continuous over here?
No.
No, it's got that little jump going on, right?
Yes.
Is the function continuous here?
No.
Continuous?
Continuous it is, but it's not
There we go.
differentiable.
That's right. It's got that weird derivative going on. Hey, thank you for calling in. You did a good job. I'll see you guys Saturday. Who's our next caller, Eduardo?
That's it.
We got another caller?
Hello?
Hi, who's out there?
It's Yvette from Sunset.
Hi, Yvette from Sunset. We're getting you on the list, Yvette. I'm so glad you called. Let me find a really good problem. Have you done...
Hey, Eduardo.
Hey, Yvette.
Eduardo gets to say hello. Have I got your picture? Eduardo's going to get your picture for me. I've got two problems. I'm going to let you pick which one you like. This problem or this problem?
The second one.
The second one. What is it about the second one you like better?
It doesn't have a square root.
I know. That's a good thing, isn't it? What have you got? Tell me what you're going to do with this problem. We're going to get your picture out in just a minute.
U sub?
You sup. Tell me what you ought to be.
10.
Good job.
Yeah,
If you tried the other one, you wouldn't get it to work, would you?
Yeah.
And then what do you need next?
Du
And that is?
equals secant squared.
Hello. Just sitting there waiting on you, right?
Yeah.
What is this problem really all about?
Natural log.
That's right. So you want to tell me that you want me to write the du over u? Would that be good?
Yes.
Okay. And then what does that equal?
Natural log of u.
Natural log of u. And what else?
Plus c.
Plus those grades you do not make. Plus c, right?
Yeah.
And then what do I put? Natural log of what?
Tangent x plus c.
That looks like a really weird answer, doesn't it? But it's exactly right. You did a beautiful job. Let me show your picture before you hang up. There you go. See that? Good. Extra bells.
Okay.
Thank you for calling in. I'm glad you guys are calling today. Who's our next caller, Eduardo?
Next, we got a mystery caller.
Frankie from Science and Engineering.
Hi, Frankie, Science and Engineering. Who's your teacher?
Miss Ada.
Miss Ada. Excellent. Have you done derivatives of arc sine?
Yeah, we barely covered that about 3 days ago.
You want to look at it? Just help me with one?
I'll try.
Okay, and we'll work together on it. Let's see if you can see this. Actually, I have a choice of arc sine or arc tan. Which do you like better?
I'll do arc sine.
Okay. Do you have a formula you could tell me so I could write it out for the audience? Or you just tell me the answer if you want to. That's okay.
U prime
U prime.
over square root of 1 minus u squared.
That is perfect. That's exactly right. Some people say du, u prime, same thing, right?
Yeah.
Okay. So, well, where's u in this problem? I'm not sure. Tell me where the u is.
4x.
That's right. There's the u right there. Okay, go ahead and give me the answer.
It's 4 over square root 1 minus 4x squared.
And I believe you could leave it just like that. If they made you go ahead, they might put 16x squared, but that wouldn't bother you, would it?
Not at all.
You'd be able to get that.
Yeah.
You want to do the arctan while we're at it?
Yeah, sure.
Okay, tell me the formula for arctan.
U prime over 1 plus u squared.
That is perfect. And now fill it in for me.
4 over 1 plus 4x squared.
That's great. Notice the differences. A negative in the arc sine and a positive here, a square root here and not one here.
Yeah.
You did a beautiful job. Double bell. Tell Ms. A-Day hi. Who's our next caller, Eduardo?
Next, we got Erica from Spruce.
Hey, Erica. How's everybody at Spruce? Erica? Hi, Erica. Are you there?
Yes, I'm here.
Excellent. How's everybody at Spruce today?
Everybody's just fine.
Good, good, excellent. Let me find a perfect problem for you, okay? What'd you guys study today, or whenever you last had class?
What did we study today? We studied, the fundamental theorem.
Fundamental theorem, all right, one of my favorite topics. All right, hold on, I'm sorry, I'm fumbling here. I gotta find that perfect paper I want to give you, okay? All right, I'm ready now. Are you ready?
Yeah.
We're going to do the first part of this one. It's got several pieces to it. Okay. All righty. We've got the position of a particle moving on the x-axis, can be found using position is sine of pi t plus 3. That's your position. I want to know the velocity. Actually, I just want you to find the velocity function. If this is position, how do you get to velocity?
So you can take the derivative?
That's right. Let's tell them that. Tell the grader. I'm going to take the derivative. All right. How do you take the derivative of sine of pi t plus 3?
Cosine
Good.
pi t.
That's right. And
Let's take 3 equals 0.
And the plus 3 goes to 0. That's right.
Yeah.
And what do you do with the chain out? Pi is like a 3. If this were 3t, what would you put in front?
Pi.
That's right. Put the pi in front. Chain it out. Put it in front. Good job. That's perfect, isn't it? I like the fact you knew the sine derivative was cosine. You got the SIG in correct. That's good, because a lot of people get those backwards and they'll lose some points. Hey, thank you for calling in. You did a good job. Bells.
Okay.
Call back. Here's our next caller.
Next, we got Kevin from Skyline.
Kevin?
Hello.
Hi. Who's your teacher?
Ms. Johnson.
Miss Johnson. All right, I got your picture here. I'm getting ready to
Hello,
show it,
everybody.
okay?
All right.
All right, here goes. Again, where you can see Kevin. I think you're got clothes for something. It's like that calculus attitude. I like that. I like that calculus attitude.
Yeah.
All right, Kevin. What's your favorite kind of calculus problem?
I don't really have one.
How about a limit?
That'd be cool.
Okay, that'd be pretty good. Let's look at this one. Let's see if I can get it in the frame. Where'd it go? Oh, Calvin, I got a message for you. Ivan says hi.
Ivan, tell Ivan I said what's up.
He says, what's up? Where do you think Ivan is?
Ivan Jones.
Yeah, where do you think he is?
Hello, everybody.
If he's not shooting the video,
Yeah, he's in the control booth.
oh, okay.
He's behind the scenes.
Oh,
All right, here we go. Limit as k goes to infinity. That's a big number. Well, it's not really a number. 2 pi minus 2 pi over e to the k, 2k. Uh-oh, what is that talking about?
the second term is going to be 0.
Oh, good job. That's exactly right, because the bottom's getting big really fast, like your salary when you graduate, right?
Right.
Really fast. So what's the limit of 2 pi?
2 pi.
Bingo, you got it. That is beautiful.
That's right.
One more? Here we go. Do one more for me, okay?
One more.
Yeah, one more.
Oh, great.
You're on a roll. You're on a roll.
Back to work.
X
Back to
goes
work.
to infinity.
Everybody.
What's
Work, work,
5x
work,
minus
work,
2
work.
over e to the x?
E is going to infinity again, so you get real small.
And so what do you get? Real small. Good
0.
job. Excellent.
To infinity
Great
and
job.
beyond.
Thank you for calling in. That was good because they weren't exactly like we usually see, but you knew how to use the rules to apply like you always do. Biggest on the bottom, that thing's going to 0, isn't it?
Right.
Thank you for calling in. You guys call back. Are we wrapping?
Anyone?
Crystal.
We got
Crystal from
Crystal
Carter.
from Carter. Hey, Crystal.
Hi.
How are you?
I'm okay.
Can you speak up just a little? It's
Oh,
probably me.
I'm
No,
doing fine.
I think
Can
it
you
was.
hear me
I think it was me, not you.
Oh, okay.
Okay. You ready for a problem? I got one here that looks really interesting. See what you think. Does that look really interesting to you?
Yes, it does.
Wow,
Looks very
that's pretty heavy.
So tell me what the answer is. Take me through the steps, okay?
It is.
What do you do first?
All you have to do is look at the sign pi 4, and that'll be your answer.
All right. You want to say sine of x is your function, right?
Yeah.
Don't go putting this in yet. What's the derivative?
Cosine.
Cosine, and now I put in the pi over 4. If I take the derivative here, they all go to 0, right? So go back to x. Now, what is the cosine of pi over 4?
Square root of 2 over 2.
Say it again, I just didn't hear you.
Square root of 2 over 2.
You said it perfectly. Square root of 2 over 2, yay! Case closed.
All right.
Good job.
Thank you, ma'am.
Thank you for calling in. Well, guess what, Eduardo? Thank you for calling in today. I want to thank my student host, Eduardo. He did a great job, got all those pictures out just the right time. We've got gift certificates for 2 lucky callers. Eduardo has the calculator set up. How many callers do we have, Eduardo?
We got 24 callers.
We have 24 callers. All right, let's get it set. Eduardo's going to tell us who the lucky winners are. 24 callers. Here are number 20 and number 3.
We got Yvette from Sunset. And we got Yvette from Mystery School.
Yvette from the mystery school, huh?
Yes.
Yvette from Sunset, and is that Yvette from maybe Skyline? We'll have to find out. We've got 2 lucky winners, and we'll make sure those gift cards get out. If it turns out that's the same person, we'll remember prep session Saturday. Be there, Townview, 9 a.m. Prizes, pizza, and some problems to work. Eduardo and I are wishing you a 5 on the exam on May the 3rd. Work hard so you can celebrate when those results come in.